Okay, so we've got the solution for the problem that was at the end of the last video here. The answers are boxed in at the bottom there, so if you got them, great. But if you're in any trouble, got the work set out there. The key here was, again, finding the sine and the cosine of theta, and then using those two values to find the sine and the cosine of 2 theta. Okay, so in this last video, we've got two more groups of identities to take a look at, but they're nicely connected, and actually they're connected to some of the identities from the last video in the double angle identities. So we're going to go ahead and take a look at a couple of those. In particular, the two of the ones for cosine of 2 theta. Now, sometimes in calculus especially, we have got something like a cosine squared or sine squared, and we need to get rid of that power before we can move on either with the proof or with the problem that we're working with. So what we're going to do is we're going to take these two, and what I'd like to do is in each of them we're going to solve them for the squared term. So in this first one we're going to solve for cosine squared theta, and then in the second one we're going to solve algebraically for sine squared theta. So you could give those a try, but it's pretty easy, and in the end what we get is what we call the power reducing identities, and we do use these quite a bit in Calc 1 and 2 with proofs and other problems. So they're good to know, but we're particularly interested in these because they're going to help us solve an issue of evaluating trig functions for exact values at some odd angles that we might run into. So here's the question that I'm gonna sort of pose, and we'll see why these can help. So if we were to consider, this is kind of like in the second video, we consider that we can find the exact value of something like the cosine of pi over 4, or the cosine of 45 degrees, if we're in degrees or radians. We know how to do this. We can draw reference triangles, unit circle, however we want to think about it, but we know that this ends up being the square root of 2 over 2. But what if we get, how about an angle like this, like the cosine of pi over 8? Now, if we were to convert this into degrees, we'd see that this is actually the cosine of 22.5 degrees. So how are we gonna find an exact value for this? Well, kind of like we did with the sum and difference when we ran into this issue of exact values for unfamiliar angles, we're gonna use identities. Now, again, if we are asked for just a rounded solution, so if you're okay with rounded, then by all means just use your calculator. But if you're asked to find exact, then this is usually a cue that we need to use identities. And that's what we're going to be interested in doing here. Now, one thing that you may notice here is that the comparison between pi over 4, pi over 8, or 45 and 22.5 is that these angles are related and that they're half of each other. And what we're going to be doing is we're going to be talking about the half angle identities. Now, if we went back up to these power reducing identities, these are where the half angle identities come from. So if we were to solve for cosine of theta and sine of theta, and we have to do a little bit of substitution. It's outlined in the book a little more clearly, but it might take a little while to do here, and I'll spare you all the proof. But if we were to solve these and use some substituting, we end up getting what we call the half angle identities, and you can see how closely they're related. Essentially, we took the square root of both sides, and we relate the angles in the same manner. We just use slightly different notation. So in both of these, the angle on the left-hand side of the identity in both power reducing and half represents half of the angle that is used on the right side of the identity. So you can kind of see this and see that they're connected this way. For us, this is going to allow us to solve this question about something like the cosine of 22.5 degrees. So here's what we're going to notice, is we notice that the cosine of, I'm going to stick with the degrees for now, of 22.5 degrees could also be written as the cosine of 45 degrees divided by 2. When we see this, this is a perfect opportunity for us to use these half angle identities. So what we're going to do is we're going to consider here that using this first half angle identity, this is where the most common mistake comes in, is identifying, well, I know that I can use the half angle identity here, and that this is going to be plus or minus the square root of 1 plus the cosine. Now, what is the theta that's involved here? Well, the theta is not 22.5 degrees or 45 degrees divided by 2. The theta is this top angle right here, the angle we've divided by 2. So the way that we would write this is it's the cosine of 45 degrees divided by 2. So again, it's important to recognize that this angle that goes in for theta is the angle that we've divided by 2 right here, not the 22.5. Okay, so let's go ahead and finish this one out. So now we've got to go ahead and evaluate this. So we know this is going to be plus or minus the square root of 1 plus. Now we just have to ask, well, what is the cosine of 45 degrees? And we know that the cosine of 45 degrees is the square root of 2 divided by 2. So we can go ahead and throw that in there. So square root of 2 divided by 2, and all of this is over 2. So we've got a little bit of simplification ahead of us, but before we do that, I'd like to address this issue right here, the plus or the minus. Now, to determine if we're plus or minus, is we have to look at our original question. So is the cosine of 22.5 degrees positive or negative? And we can answer that question by thinking about, well, what quadrant is 22.5 degrees in? And this is an angle that falls into quadrant 1. So the angle 22.5 degrees is in quadrant 1. The cosine is positive in quadrant 1. So we know that the cosine of 22.5 degrees is going to be a positive value. So that's how we can make that determination. So now we can go ahead and we can go back to solving this. So this is going to be equal to positive the square root of 1 plus the square root of 2 divided by 2 all over 2. Now, I'm going to warn you, this gets a little bit tedious to simplify this, but it's not too bad. So the first thing we're going to do is we're going to add these two numbers up in the numerator. So I'm going to drop the positive since it's sort of assumed. So we've got the square root of 2 over 2 plus the square root of 2 over 2, and this is all over 2. You're going to hear me say 2 a lot in this problem. So we add these numerators, or these two terms in the numerator together, and we get 2 plus the square root of 2 divided by 2, and all of this is all over 2. So we're taking a fraction, we're dividing that by 2. So what we get here is we get 2 plus the square root of 2. Divided by 2 is the same as multiplying by a half, so that's going to be all over 4. And then the last thing that we can do is we can take the square root of the top, the square root of the bottom, and we end up with the square root of 2 plus the square root of 2. And now this is all over the square root of 4, because we can break that up using properties of square roots. And we end up with 2 plus the square root of 2 all over 2. And I would not be surprised if WebAssign wants you to write it as this: 1/2 times the square root of 2 plus the square root of 2. So I would not be surprised if that's the way that solution needs to be written. All right, so we had to do a couple of things. The biggies were finding out a way to take this angle, 22.5 degrees, write it as some known angle divided by 2, use the half angle formula, and then determine if it was positive or negative. So I'd like to do one more example to kind of illustrate how this would work. All right, so let's try this with the sine of pi over 12. All right, so it might not be a bad idea, again, to just go ahead and try converting this into degrees. So we could say, well, this is the same as the sine of 15 degrees. So is this a good candidate for using the half angle identity? Yeah, it is, because we can look at this 15 degrees and we can say, well, 15 degrees is the same as 30 degrees divided by 2. So we're going to go ahead and we're going to write this as the sine of 30 degrees divided by 2. And this is what we're going to use our half angle identity for. So let's go ahead. I'm just going to move this down here. So the sine of 30 degrees divided by 2 is going to be equal to plus or minus the square root of 1. Now we're going to use the half angle formula for sine of theta divided by 2. And it's going to be minus the cosine of 30 degrees divided by 2. Okay, so here are 2 questions that we're going to need to ask here. First off, what is the cosine of 30 degrees? Cosine of 30 degrees is going to be equal to the square root of 3 divided by 2. So that's done. Now the second question is the sine of our original angle, which is pi over 12, positive or negative. So 15 degrees, pi over 12, first quadrant, so we know that it's going to be positive. So now we can go back and we can just do the arithmetic necessary for this. So we know that's positive, so now we've got the square root of 1 minus the square root of 3 divided by 2 all over 2. And now it's the same process that we had with that last one. We just got quite a bit of algebra ahead of us. Not algebra, I guess it's just arithmetic. So 2 over 2 minus root 3 over 2 all over 2. Bring this together, we get 2 minus root 3 over 2 all over 2, which will give us the square root of 2 minus the square root of 3 all over 4. This is going to give us, we take the square root of the top and the square root of the bottom, get 2 minus the square root of 3 over 2. And this is the same as 1/2 times the square root of 2 minus the square root of 3. And then this would be our final solution. Either of those two last, I think, would be acceptable. But again, I think WebAssign is going to want you to use this one. Now again, we could have actually done this same one using the sum and difference identities like we did in the second video, but you've got some options. So just be aware of that. Okay, so that's the last one, and I will see you guys in class.